Hi everybody. In this video I'm gonna talk about geometry. Geometry actually at the beginning was the knowledge of measuring the land. But right now actually is the bridge or is the connection between numbers and figures. It's a start, the geometry actually start with point. In the real world, in this world, whatever that we can see, whatever object that is around us, it should have a 3-dimension: length, width, and height. Every object that we can hold it, we can feel it, we can move it, it should have this 3-dimension: length, width, and height. Now, when we are talking about 2-dimensional surface, it means it has only length and width. Same as the surface of this board. I can feel it, but I cannot move it, because if I want to move it, it needs to have a little bit of thickness to be able to move it. The thickness means the height. Or the surface of this floor, the floor of the room. If we want to just touch the surface, it can have 2 dimensions, length and width. But if we want to move the surface, then it should have the height. Now, when we start talking about point, in the theory, point is something with no length, no width, no height. No length, no width, no height. Actually, such a thing is not possible to exist in the real world. We cannot see it, we cannot feel it, we cannot touch it. It's something with no length, no width, no height. But in theory, this is the definition of point. Even for this point that you are seeing here, it has a small amount of length and width and a little amount of height, which is the thickness of the color of the glue that I'm writing in this one. But in theory, the point, which it means with no length, no width, no height. Now, what is line? Point, no length, no width, no height. Line is created with the movement of a point. If we have a point and we move the point, okay, the effect of this movement, it's create a line. Or we can say line has only length, no width and no height. In theory, in the definition, line has only length, or line is created by movement of a point. Again, line is continuous in both sides forever. When we are talking about the line, it means it from both sides is continued forever. Again, in the real world, we cannot have such a thing that it's moved from both sides forever. So, if we have something, a part of the line, which is started from a point, we can call it point A, and end to another point, as an example, point B. A part of a line with a starting point and ending point. Then we call it, the name of this part, we call it segment. Segment actually is a part of a line with a starting point and ending point. We can name the segment with the starting and ending point. As an example, segment AB or segment BC. Segment AB and segment BC. For the segment, same as other calculation, as I told you, geometry is a connection of figures and numbers. For the segment, we can add or subtract the segment. As an example, we can say segment AB, and this small bar above AB, it means the sign for segment. Segment AB plus segment BC. Can you see we are doing the addition of the segment? Segment AB plus segment BC, then it gives us segment AC. Or segment AC. Segment AC minus segment AB, AC minus AB, then it gives us BC. As you see, we can add and subtract with the segments. Line, point, line, and segment. Point, something with no length, no width, no height. Line has only length or created by movement of a point. Segment is a part of a line with a starting point and ending point. Now, plane surface. Plane surface is any surface with the two-dimensional surface, same as the surface of this board. Okay? Or with the three-dimensional, we call it a space. A space is a three-dimensional object. Any object that we can, same as a cube, rectangular prism, these markers, all of this one occupied some part of the space, and they have three dimensions: length, if this is the height, length, and width. Okay. Now, when we are talking about the line, as I told you, line, it means continued from both sides forever. These two arrows in two sides of the line, it tells us that they are continuing from both sides. We can say this one line 1 and line 2. Line 1 and line 2 can have two different situations. One situation is they never touch each other, or they never intersect each other. Imagine that they are continuing from both sides forever and they never touch each other, they never intersect each other. We call this situation we call parallel line. Parallel lines. Parallel lines means two lines that always have the same distance and they never intersect each other. Now, what is the other situation? Two lines, line 1 and line 2. Line 1 and line 2. They intersect each other in one point. They are intersecting line. For showing the parallel line, we use this sign. Line 1 is parallel to line 2. Yeah? This two vertical small bar is the sign for parallel line. Line 1 is parallel to line 2, or line 1 and line 2 are parallel. These two lines, line 1 and line 2, they are intersecting lines. They intersect each other in one point. Okay? Remember, two lines, if they intersect each other in more than one point, as an example in 2 points, let's say this is line 1 and another line, line 2. If they have more than one point in common, it means these two lines, actually they are making one line, because when these two lines, if they have one point intersect each other in common in this area, as an example point A, and another point common point B, then it means all the other points should be common between these two lines, or actually these two lines are make one line. So we have two different situations for the line, parallel line or intersecting lines. This, the third situation, actually is going to be make only one line. Now, after finishing point, lines and segments, then we have the definition of angles. Before explaining the angles, if a line, as an example, line 1, okay, Line, as I told you in definition, has no starting point and no ending point. But if a line have a starting point, let's say this line is started from point A, then we call it ray. Ray is a line with only a starting point. From other side is continuous forever. So the name of this one is ray. If two rays start from the same point, as an example, let's say ray 1 and ray 2. Ray 2. Ray 1 and ray 2. Let's say these two rays, both of them are started from point A. Then they create angles. Angles is created by two rays starting from the same point. Okay, these are the definition of angles. Angles are two rays starting from the same point. The name of the starting point in this picture I named it A. The name of the starting point we call it vertex. Okay, vertex is the starting point of two rays, or we show it is this intersecting of these two rays. Now, and this was the definition of the angle. For showing the angle, for naming the angle, we can name it with the vertex, with the name of the vertex. As an example, in this case, I can name this one angle A. The sign for showing the angle is this sign. This is the sign of angle, angle A. This is one method of naming the angles. The other method of naming the angles, we can write the name of the angles at the close to the vertex. As an example, angle A. Okay, so again we can call it angle A, or angle theta. Theta, they are theta, alpha, beta, they are Greek name, Greek alphabet. So I can say angle alpha, or angle theta, angle alpha or angle theta. They are different way of naming the angles. Angle theta. Okay, angle alpha, angle theta. The other way of naming the angles, using three letters. Let's say angle A O B. Angle AOB. We can use three letters to name the angle. And this is the sign of the angle AOB. Remember, the middle letter is always the letter of the vertex. AOB. If we have two angles that they are beside each other or adjacent to each other, as an example, this one. Okay? Now, if I name this side C, this point C, then I can name this angle AOC. Angle AOC. AOC. Or angle AOB. Or angle BOC. BOC. These are the different type of naming the angle. Or I can name it angle theta or angle. Let's don't use this Greek letters to make it less confusing. So angle A or angle B, by using these letters close to the vertex inside the angle. These are different methods of naming the angles. Now, one complete revolution. Let's say just imagine a circle. One complete revolution of circle. It create one complete revolution. It create 360 degree angles. Okay. It create the measure of one complete revolution is 360, and the sign is this small circle around this one, which is degree. 360 degree. 1/4 of complete revolution. if I make it to the 4 equal part, 1/4 of complete revolution, we call it right angles. Okay. Now, what is the right angle? Is the 1/4 of a complete revolution, or the side, the measurement is 90 degree. 90 degree angles, we call it right angles. Let's start from this point. Right angles, right angle is equal to 90 degree. Right angle is equal to 90 degree. Any angles, and this is the sign of the right angle. This is small corner in this one is a right angle, yeah? Is the sign for right angle. We show it with this small corner. Let's say angle AOB. Because of this sign, we can say this is the right angle, and how much is the size? 90 degree. Any angle less than right angle, we call it acute angle. Acute angles. Yeah, is less than 90 degree. Any angle less than 90 degree, we call it acute angle. I forgot this. Acute angle is less than 90 degree. Any angle greater than 90 degree. And let's show this one as an example for acute angle. This is acute angle. This sign is 90 degree. Okay, so acute angle less than 90. Let me just, acute is less than 90. Degree, same as this angle, angle COD. This one is acute angle. Any angle greater than 90 degree, we call it obtuse angle. Obtuse is greater than 90 degree. Okay. As an example, this angle. Okay. Angle MON. Can you see? If I use the 90 degree angle as a reference, if I use the 90 degree, look at this one, this is the 90 degree, this angle is 90 degree, COB is less than 90, then we call it acute angle. This angle, this one, the red part, this one is 90 degree, and MON, this one is N. And MON is greater than 90 degrees, so we call it obtuse angle. Now, one other type of the angles is a straight angle. Okay, I need to write it here. A straight angle is equal to 180 degree, or half of a complete revolution, and we show it in this format, which is 180 degree. Okay, half of the complete revolution. One complete revolution is 360 degree. Half of a complete revolution is 180 degree, which is, we call it a straight angle. Now these are the different type of angle. Right angle is 90 degree. Acute angle is less than 90 degree, same as 60 degree, 65 degree, 80 degree. All of them are acute. Obtuse angle is greater than 90 degree, same as 95 degree, 100 degree, 120 degree. All of them are greater than 90 degree, and it should be less than 180. As an example, greater than 90, less than 180. Between these two angles, 179 degree again is obtuse angle. A straight angle is equal to 180. These are the different type of angles. From this type of angles, the right angle is very famous angle or very important angle. If you look around whatever you are sitting right now, you can see hundreds of right angle just around yourself. Okay. As an example, the corner of the desks that we are sitting before it is right angles. Any intersection of the wall and the floor, the intersection of wall and floors is right angle. The intersection of the wall and ceiling is right angle. Most of the intersection of the street, when you are moving around the city, most of the streets are intersect each other in the right angle format. As you see, all the corner of the tiles that we are using in the floor, they are right angles. Now, we have two more things that we need to learn in this video. Complementary angles and supplementary angles. Complementary angles. What are the complementary angles? What is the complementary angles? If sum of two angles, let's say angle A, let's use the capital letter. Let's say angle A is 70 degree. And let's say angle B is 20 degree. If we add angle A plus angle B, what is the result? 70 plus 20. Then gonna be 90 degree. If sum of two angles be 90 degree, we call them complementary angle. Okay, so what are the complementary angles? The angle that if we add them, the result be 90 degree or right angle. We can design many questions related to this format. As an example, let's say angle A is 55 degree. And angle B is complementary of angle A, or angle A and B are complementary angle, and angle A is 55 degree. How much is angle B, or find angle B? When angle A and B are complementary angles, it means if we add them, the result should be 90 degree. When angle A is 55, how much is angle B? 90 minus 55, which gonna be 35. So angle A is 35 degree. This is one example of how you can face a question related to the complementary angle. The other type of the angle is supplementary angle. Supplementary angles supplementary, sorry that this one I don't know why is supplementary angles. if sum of two angles end up to 180 degree, let's say angle A is 120 degree, which is up to its angle because it's greater than 90, and let's say angle B is 60 degree. 60 degree is acute angle. But if we add A and B, angle A plus angle B, what is the result? 120 plus 60 is going to be 180 degree. If sum of two angles end up to the 180 degree, then these two angles, we call them supplementary angles. Supplementary angles are the angles that when we add them, the result is going to be 180. Again, we can have this type of question. Angle A is 65, angle A is 65 degree, and angle B is supplementary angle of A, or angle A and B are supplementary. Angle A is 65. What is the size of angle B? Because they are supplementary, it means some of them should be 180. When one is 65, for finding the measure of the other one, just subtract from 180. 180 minus 65, then what's going to be? 115. Okay? So this is another type of question that we may face related to the supplementary angle. Now we learn about point, line, situation of two different lines with each other, can be parallel or can be intersect, angles, and different type of angles. One more thing that I need to explain: if two lines intersect each other, line 1 and line 2 are intersect each other, and the angle between them are right angle. If two lines intersect each other with the right angle, these two lines, we call them perpendicular. Perpendicular line, let me just write the spelling. This one, perpendicular. I'm checking the these two lines, then because when they are intersecting each other, they are creating right angle or 90 degree angle. We call line 1 and line 2 are perpendicular, and we showed with this sign. Line 1 is perpendicular to line 2. Line 1 is perpendicular to line 2. Remember, for the parallel line was two vertical bar. Line 1 is parallel to line 2, or line 1 is perpendicular to line 2. Okay, that's fine for this video. I'm gonna talk about figures, triangles, and other figures in the next video. See you up to then. Bye.